Back. Okay, we're in chapter 8, section 4. We're doing the odds now as classwork. You're doing the evens tonight on page 139. For homework, here we go. Number 1. In how many ways can we choose 2 puppies out of a litter of 12 puppies? Well, that's easy. This one's about when to divide, when you have repeated letters, that kind of stuff. But we don't have, let's say these are 12 different puppies, right? So I'm going to say show number of choices equals, well, I could choose any of the 12 for the first puppy times any remaining 11 puppies, and that's it. So this time, when do we divide? We don't divide this time. Gotta know when to fold them. Better know when to play them, right? So in this case, we're not going to be dividing. All right, now look at number 3. How many words can we make from the letters Tennessee? Well, if these were different letters, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9 different letters. It would just be 9 factorial, right? But the E's are not different. So we're repeating the E's. There are 4 E's. It's like we're repeating 4 different orders of, imagine there's 4 different letters, 4 different orders. That's 4 factorial we've repeated. We got to get rid of. And the same thing with the S's. We got 2 factorial. All right, so this is what I'm going to do. I'm going to write the factorial function. But last time we wrote an iterative function, in other words, using a for loop or a while loop. Now I'm going to use a recursive function. Now, factorial is usually defined for any non-negative integers, 0, 1, 2, and 3. 0 factorial is 1. We'll get into that. 1 factorial is 1. 2 factorial is 2 times 1. 3 factorial is 2 times 3 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which is 24, like that. All right, so I'm going to make this a recursive method. I need a base case, and then I need, if I don't enter the base case as my input, I'm going to have to make sure that I have successive recursive calls where you get closer and closer to the base case, so you don't have infinite recursion. So I'm going to say this: if n is 0, the input is n, or n is 1, I'm simply going to return 1. All right, 0 factorial is 1 and 1 factorial is 1. But otherwise, now this is another way. It's not an else, because I need to return something, right? So I don't want an else here in case somehow we don't get to the else part. So I'm just going to return right away n times the fact of n minus 1. Why? Because like 4 factorial is 4 times 3 times 2 times 1. That's 4 times 3 factorial, right? And 3 factorial is 3 times 2 times 1, 2 factorial. Oh, okay. All right, let's see if this works. Show, let's see, the fact of 0 should be 1, right? All right, let's do that. That's what we get 1. And we do. Okay. The fact of 1 should be 1. All right. Let's see if we still get 1. We do. Okay, good. The fact of 2 is 2 times 1, which is 2. Whoops. And 2, right? Okay. The fact of 3 is 3 times 2 times 1, which is 3 times 2 factorial. It's 3 times 2 is 6. Oh, okay. That should give me 6. Let's see. Yep. All right, so what's 4 factorial? 4 factorial is 4 times 3 times 2 times 1. 4 times 3 factorial. 4 times 6 is 24. Okay. Right. So what's 5 factorial? It's going to be 5 times 24, which is 4 factorial. Okay. So what's that? 120? Just one more, like that. 120. If I put in 5, I should get 120. And right. Okay, so this works. So that's all right. So that's not what I'm going to output. I'm going to say this. I'm going to say number of words equals, okay, it's going to be 9 factorial, which is, what is that? 362,880 divided by, let's see, the E is repeated 4 times, so we got to get rid of the 4 factorial that we repeated. Fact divided by factor 4. So this is when you divide right here, when you're repeating the letters. Okay, so let's see what that is. So divided by what is 4 factorial? 24. So that divided by 24 is 15,120. But also, we're repeating the s's, so let's divide that by 2 factorial. In other words, just divide by 2, but I'm going to say 2 factorial. And so we end up with 7,560 words. This is 4 e's, there's 2 n's. Oh, wait, there's 2 n's. Oh, I didn't do the n's. Oh, I got to divide by 2 factorial again. Aha. All right, so the 4 factorial is for the e's, the 2 factorial is for the n's, and the 2 factorial is for the s's. Here, there you go. Right, Tennessee has 2 s's, right? Yep. And so the final answer is I get 3,780 arrangements. Okay, you know, I put that in the wrong place. Let me put that after the commentary for 3. So I'm going to copy all of this. I'm going to cut all of this and put it here. That's what I meant. And perfect. Okay. All right, number 5. In how many ways can we color the 6 faces of a cube in 6 different colors? The cube can be rotated any way you want. The colorings are considered the same. So if you're talking about 6 different colors, that's 6 factorial. But you're doing 6 different sides. So what? All right. So what if? Let's think about this. All right. Let's say we stand the cube on one side, and then there's 4 different rotations you can see on each side, right? But there's 6 different ways you can stand the cube and have different colors on each side, right? Okay. So that's going to repeat. That's a repetition again. All right. So I'm going to say this. Number of colorings, I guess. Show number of color patterns on the cube, right? It's going to be 6 factorial because they have 6 sides, right? So fact of 6, which is 720, okay. But then let's divide that by 6 different ways you can place the cube on its face. Put the face on, let's say, on the table, right? Six different ways. So divide that by 6, which is really 5 factorial. Okay, or is it 120? But then you could spin it around 4 different ways. So that's 4 different repetitions there too. So divide that by 4. And so 5 factorial divided by 4 is 5 times 3 times 2 times 1 is 30. That's it. 30 different ways of doing it. Alrighty, good. All right, and number 7. How many ways are there to place 8 rooks on a chessboard so that none of them threatens any other? Well, think about it. If you know how to play chess, a rook can move horizontally or vertically. So if any rook is in the same row with another rook, it's threatening that rook. It could take it. And same thing if any rook is in the same row as any other rook. So I have to put one row. Say I put a rook on row 1. There's 8 rows and 8 columns on a chessboard, right? Say put a rook on, say, the leftmost square of row 1. We're going to put another rook. I have to put it in the next row, but not in the same column. So that would be one less choice. And then in the next row, not the same column. And the next row, not the same column. The next row, not the same column. So I'm going to say I could put the rook anywhere, the first rook anywhere on the first row. Then in the second row, I can put it anywhere on this, I have 7 spaces. I can put it where it doesn't match the same column of this first rook, right? Then the third row, I have 6 spaces where I can place the rook where it's in that row, but not in the column of the other 2 rooks. So isn't this 8 factorial? 8 for the first row times 7 times 6 times 5 times 4 times 3 times 2 times 1 for the last row. That's all it is. Okay, so I'm going to say show number of placements equals. And it's just simply 8 factorial. Fact of 8. And so how much is that? That's going to be 40,320. Okay, that's it. All right, so there's your code for number 1. Let's make it a little bit bigger. A little bit smaller, maybe. Okay, there's the code for number 1. I don't know if I can fit the questions in here. Trying to fit the question. Okay, here's the code for number 1, and the code for number 3, and the code for number 5. There's the question, and the code for number 7. A lot of this uses factorials. And here's the output for number 1. Here's the output for number 3. There's the output for number 5. And there's the question and the output for number 7.